Hello everybody, we're getting ready to do section 16, SAT Math Level 2 preparation. Section 16 is counting, just called counting. You got 10 points in your notebook guide, have that out. You got 14 points here for your classwork sheet, have that out. Student name, date, period, due date for onliners, home. And let's go right into our first notebook entry here. Counting problems usually begin with the phrase how many or the phrase in how many ways. Illustrating counting techniques by example is best. So to illustrate these issues here, we'll go into examples. If you need to brush up on your what's called counting problems, I have packets for that, review packets available for those. But this is what we'll go into here. A certain sports club has 50 members. Of these 35 golf, 30 play soccer, and 18 do both. How many club members do neither? So we know who does what. How many club members do nothing? Okay, so add 35 and 30, 35 up here and 30, we know they play soccer. Then subtract the 18 up here, we know 18 of these will play both. This makes 47 who golf and play soccer or do both. Therefore, only 3 times, so because we have 3 categories here, 3 times 50, which we have total of 50 minus 47 who qualify for each one of these categories, do neither. So 3 times 50, 3 times 3 would be 9. So B here, among the seniors at a small high school, 80 take math, 41 take Spanish, and 54 take physics. 10 seniors take math and Spanish, 19 take math and physics, and 12 take physics and Spanish. 7 seniors take all 3. How many seniors take math but not Spanish or physics? So wow, what do we got going on there? Venn diagram, I think, will be the best way to organize this. So here's our Venn diagram here. We have our 3 here. We have our 3. What's our 3 up here? 7 seniors take all 3 here. 7 seniors here take all 3. We got 80 who take math. 80 who take math. 41 take Spanish. Here's Spanish, here's math. So 58, 3 and 7 is 10. 22 and 58 would be our 80 there. 54 take physics. Here's our physics here. 12, 7, and 5 take both here. 12, 7, and 5. Let's see, 54 take physics. Wait a minute. Where am I at? And then 10 seniors take math and Spanish. 10 seniors take math and Spanish. So here's our math. So here's our 10 here. 10 of them take Spanish and math. So that's where that 3 comes in. And let's see, 12 take physics and Spanish. So 12 take physics, and here's our 12 there of those. And 7 seniors take all 3. 7 seniors are right here. They take all 3. How many seniors take math but not Spanish or physics? So for that, how many seniors take math? They take math but not Spanish or physics. That'd be over here. That'd be 58 would be that number. By using a Venn diagram. So it'll be 58 would be not seniors. Start with a 7 who take all 3 courses. Since 10 take math and Spanish, this leaves 3 up here who take math and Spanish but not physics. Use similar reasoning to see that 5 take physics. 5 take physics and Spanish but no math, which is over here. 5 take Spanish. Let's see, 5 take physics and Spanish but not math. That'd be there. And 12 take math and physics but not Spanish. And 12 take math and physics but not Spanish. So that'd be that 12 there. Finally, using the totals for how many students take each course, we can conclude that 58 times 80 minus 3 minus 7 minus 12 take math. So that's how we get our 58. 80 minus 3 minus 7 minus 12 gives us our 58. Take math, but not physics or Spanish. Many other counting problems use the multiplication principle. Okay, moving on now to slide number 4. C, suppose you have 5 shirts, 4 pairs of pants, and 9 ties. How many outfits can be made that consist of a shirt, a pair of pants, and a tie? So how many outfits can we make out of this? For each of the 5 shirts, you can wear 4 pairs of pants. So there are 5 times 4 equals 20 shirt pant kind of combinations. For each of these 20 shirt pant combinations, there are 9 ties. So there are 20 times 9 would equal 180 shirt pant tie combinations. D, 6 very good friends decide they will have lunch together every day. In how many different ways can they line up in the cafeteria line? So I have 6 very good friends here. Any one of the 6 could be first in line. For each person who is first, there are 5 who could be second. This means there are 30 times 6 times 5 ways of choosing the first 2 people. For each of these 30 ways, there are 4 ways of choosing the third. This makes 120 times 30 times 4 ways of choosing the first 3 people. Continuing in this fashion, there are 6 times 5 times 4 times 3 times 2 times 1 would equal 720 ways these 6 friends can stand in line in a cafeteria line. This means that they have perfect attendance for 4 years of high school. They could stand in line in a different order every day because 720 equals 4 times 180. The math team at East High School has 20 members. They want to choose a president, a vice president, and a treasurer. And how many ways can this be done? So any one of the 20 members could be president. For each choice for president, there are 19 members who could be vice president. For each of these 380 ways of choosing a president and vice president, there are 18 choices for treasurer. Therefore, there are 20 times 19 times 18 equals 6840 ways of choosing these 3 club officers. F, the student council at West High School has 20 members. They want to select a committee of 3 to work with the school administration on policy matters that affect students directly. How many committees of 3 students are possible? So, okay. This problem is similar to example E. So we will start with the fact that if they were electing 3 officers, the student council would be able to do this in 6,840 ways. However, it does not matter whether member A is president, B is vice president, and C is treasurer, or some other arrangement as long as all 3 are on the committee. Therefore, we can divide 6840 by the number of ways the 3 students selected could be president, vice president, and treasurer. This latter number is 3 times 2 times 1 equals 6. So there are 1,140 committees of 3. There's 1,140 possibilities for committees of 3. Counting problems like the ones in D, E, and F occur frequently enough that they have special designations. Example D asks for the number of ways 6 friends could stand in line. By using the multiplication principle, we found that there were 6 times 5 times 4 times 3 times 2 times 1 ways. A special notation for this product is 6 factorial. In general, the number of ways n objects can be ordered is n factorial. So remember factorials? If you're a little rusty on that, I have packets for that too. Example E asks for the number of ways you could choose a first president, a vice president, and third person, a treasurer, out of 20 people. So R equals 3, N equals 20. So we need to choose 3 out of 20. The answer is 20 times 19 times 18, or 20 factorial over 17 factorial. This is your formula for finding that. 20 factorial over 20 minus 3 factorial. In general, there are n factorial over n minus r factorial permutations of r objects of n. This appears as NPR in the calculator menu. In example F, we were interested in choosing a committee of 3 where there was no distinction among committee members. Our approach was to first compute the number of ways of choosing officers and then divide out the number of ways the 3 officers could hold the different offices. This led to this computation here, 20 factorial over 17 factorial, 3 factorial. And again, this is the formula we use here for that. And you should be familiar with that, class. In general, the number of ways of choosing r of n objects is n factorial over n minus r factorial times r factorial. This quantity appears on the calculator menu as NCR. However, there is a special notation for combinations. NCR or n choose r equals n choose r, the number of ways r objects can be chosen from n, or n choose r. Calculator commands for all 3 of these functions are in the math probability menu. And then here is your math probability menu. This is what it looks like here. Here's NCR, here's NPR, factorial, and these other, which are more of a statistical. And then over here, it's in the probability drop-down menu here. These 3 commands can also be found on scientific calculators. And that is your section 16 SAT Math Level 2 Prep. Animated PowerPoint mathvideo@AOL.com. For questions or course materials are these review packets that I can get you. Thank you.